In this video, I'm going to take a look at the grade 10 2024 November paper 1. Question 1.1. The value of the square root of 70 lies between two integers. Determine these two integers without finding the exact value of the square root of 70. To answer this question, I'm going to write out our perfect squares. 1 squared is 1, 2 squared is 4, then 9, 16, 25, 36, 49, 64, 81. Now 70 lies between these two values. So 70 lies between 64 and 81. Now we square root. So square root of 70 will lie between the square root of 64 and the square root of 81. So the square root of 70 lies between 8 and 9. Question 1.2. Convert the following recurring decimal fraction to a common fraction in its simplest form. So step 1 is to let x equal 0,2323 recurring. Now the idea here is to get rid of the recurring decimal, so we need to multiply it by some factor of 10. So I'm going to move this 1, 2, so 2 places until that point where the decimal starts repeating itself again. So 2 places means I'm going to multiply it by 100. So 100x is going to equal 23,2323 ... Next I will say 100x minus 1x is equal to 23,2323 recurring minus 0,2323 recurring. Now, if you'll notice that the decimals cancel, and I'm left with 23 minus 0, which is 23, and 100x minus 1x is 99x. So x is equal to 23 divided by 99. Question 1.3. Simplify the following completely. Now that's worth 2 marks, so it's probably just expanding. So I'm going to write it out here. 9x squared minus 3xy plus y squared, that's one bracket, and multiply by 3x plus y. Now what I'm going to do is I'm going to multiply every term in the second bracket by every term in the first bracket. Doesn't really matter which way you do it as long as you do it. So I'm going to multiply it like so. So that times that times that, and then that times that. And likewise, I will multiply there, I will multiply there, and lastly there. So I'll get started. So 9x squared multiplied by 3x is going to be 27x to the power of 3. Then 3x times minus 3xy is giving me minus 9x squared y. Then 3x times y squared is positive 3xy squared. So that's done. I can start multiplying the y. So y times 9x squared is positive 9x squared y. Then y times minus 3xy is minus 3xy squared. And lastly, y times y squared is y to the power of 3. We can now identify like terms. This and this are like terms, and this are like terms. So minus 9x squared y plus 9x squared y will cancel. And similarly, 3xy squared minus 3xy squared will cancel, leaving us with simply 27x to the power of 3 plus y to the power of 3. Now, this is actually sum of cubes. So the question that they've given us at the beginning was the factorized form of that. So if you spotted it at the beginning, you could have simply went to the final answer. The same thing. Question 1.3.2. We have 3 over x minus 4 plus 2 over x plus 3 minus 21 over x squared minus x minus 12. Now, there's no equal sign here, so I have to get an LCD. And the first thing I want to do is I want to factorize this denominator, this trinomial. So I'm going to have x minus 4 and then x plus 3. Then there's a 21 on the top, and then 2 over x plus 3, and then plus, and 3 over x minus 4. Now, I can see that I can get a common denominator of x minus 4 and then x plus 3. So next step would be write one big fraction. I have x minus 4 and then x plus 3. Now I need to figure out what must I multiply x minus 4 by to get x minus 4 x plus 3. Well, that's simple. I must multiply this, let's use a different color here, by x plus 3. And what I do to the denominator, I must do to the numerator. So that's going to be x plus 3 as well. So this first part is going to be 3 into x plus 3. Now for the second fraction, what would I have multiplied x plus 3 by to get the denominator x minus 4 x plus 3? Well, I would have multiplied by x minus 4. So what I do to the bottom, I must do to the top. So here I will have plus 2 into x minus 4. And then lastly, minus 21. Now I can expand these and then simplify. So I will get 3 times x is 3x, plus 3 times 3 is 9, and plus 2 times x is 2x, and then 2 times negative 4 is negative 8, minus 21. And that's all over x minus 4 and then x plus 3. Now I haven't expanded the denominator because most times something will need to cancel. So now I can simplify like terms here. So 3x plus 2x will give me 5x. So here I'm going to have 5x. 9 minus 8 is 1. And 1 minus 21 is minus 20. And that's all over x minus 4 and then x plus 3. Now from my numerator I can take out a factor of 5. So 5 into x minus 4 divided by x minus 4 and then x plus 3. Now the x minus 4 can cancel and I'm left with a final answer of 5 over x plus 3. Question 1.3.3 says 5 to the power 2n plus 2. So I can rewrite that as 5 to the power 2n times 5 to the power 2 minus 3 times 5 to the power 2n plus 1 can be rewritten as 5 to the power 2n times 5 to the power 1. That's divided by 25 to the power n can be rewritten as 5 squared to the power n and then multiplied by 4. Now in my numerator I can take out 5 to the power 2n as a common factor. So 5 to the power 2n, open bracket, 5 squared minus 3 times 5. And that's divided by, in my denominator, I can simplify the 5 squared to the power n as 5 to the power 2n, and multiplied by 4. The 5 to the power 2n cancels, and that leaves me with 25 minus 15 divided by 4. So that's equal to 10 divided by 4, which is equal to 5 over 2. Question 1.4.1, factorize. 1.4.1, x squared minus 13x plus 42. So this is simple. You find two numbers such that when you multiply, you get positive 42, and when you add, you get negative 13. So the numbers are going to be x minus 6 and then x minus 7. Question 1.4.2, m squared, so m squared plus m into 4 plus n plus 4n. Now first let's simplify by opening up the brackets. So m squared plus 4m plus mn plus 4n. Now, I can take out m as a factor for the first term here. So I'll be left with m into m plus 4. And then I can factorize that part by taking out n as a factor. And I'll be left with m plus 4 as well. Now, because m plus 4 is repeated, I can write it as one factor. And then what's left in the next bracket. So that's my final answer. Question 1.4.3, factorize 2y minus 250y to the power 4. Now I'm going to take out 2y as a common factor. So 2y into 1 minus 125y to the power of 3. Now this can be factorized. This is difference of cubes. So I'm going to have 2y into, now the first thing is you're going to have a small bracket and then a larger bracket. In the first bracket, you're going to match the sign of the thing that you're factorizing, so a minus. Then you change the sign, you'll have a plus and then a plus. Now the cube root of 1 is 1. The cube root of 125y cubed is 5y. Now the next bracket is simply made using the previous bracket. So 1 squared is 1, 5y squared is 25y squared, and the middle term is simply the product of these two. So 5y times 1 is 5y. And that's our final answer. Question 2 says, well, 2.1, solve for x without using a calculator. 2.1.1, 6x squared minus x minus 1 is equal to 0. Now, of course, the easy way is to use the calculator, but we need to show all working. So if you have a Casio calculator, it can solve it for you. So you'll enter this in your calculator and you'll get x is equal to minus 1 over 3 or x is equal to half. Now what we want to do from here is we want to get the brackets. So we'll have a bracket here or a factor and a factor here, and that's going to equal 0. Now we need to manipulate both our solutions so that it's equal to 0. So first I will take the 3 across, I'm going to get 3x. Then I'll take the minus 1 across, I'll get plus 1. Likewise, for the other side, I will do take 2 across, I will get 2x. And then take the 1 across, I will get minus 1. And that's my answer. Question 2.1.2, we have 3 to the power 2x minus 1 is equal to 1 over 243. Now 243 can be factorized. If you enter it on your Casio calculator, it can write it. It can factorize it for you. So 3 to the power 2x minus 1 is equal to 1 over 3 to the power of 5. 243 is equal to 3 to the power of 5. Now we can rewrite this. If I take this to the top, I change my exponent. So 3 to the power negative 5 is equal to 3 to the power 2x minus 1. Now that the bases are the same, I can drop the base and I can solve for the exponent. So 2x minus 1 is equal to negative 5. So 2x is equal to negative 5 plus 1. 2x is equal to negative 4. X is equal to negative 2. Question 2.2 is an inequality. The inequality is x plus 3 over 2 lies between negative 1 and 5. So first thing we need to do here is to multiply both sides by 2 to get rid of that denominator. So x plus 3 will lie between minus 1 times 2 is minus 2 and 5 times 2 is 10. Then we can take the 3 across to both sides. So x is going to be between minus 2 minus 3 is minus 5 and 10 minus 3 is 7. Now moving on to question 2.3. At a restaurant, a glass of orange juice costs 4 rand more than a glass of iced tea. It is further given that 5 glasses of orange juice and 3 glasses of iced tea together cost 84 rand. Let x be the cost of orange juice and let y be the cost of iced tea. Set up a system of equations that represents the above information. So 2.3.1. So we'll say that orange juice, so X, is equal to the cost of iced tea, which is Y, plus 4. Then we can say 5 glasses of orange juice, so 5X, plus 3 glasses of iced tea, so 3Y, is equal to 84. So those are our two equations. 2.3.2 says, hence determine the individual cost of orange juice and iced tea. So we're basically solving simultaneously. Now we've already got an expression for X, so I'm just going to substitute this in here. So 5 into Y plus 4 plus 3Y is equal to 84. So 5 times Y is 5Y, 5 times 4 is 20, plus 3Y is equal to 84. So 5Y plus 3Y is equal to 8Y, and 84 minus 20 is 64. So Y is equal to 64 divided by 8, which is 8. That means X is equal to 8 plus 4, which is 12.
So question 3.1 reads, consider the following linear number pattern: 8, 3, negative 2. 3.1.1 reads, write down the next term of the pattern. So if we look at the constant difference here, it's decreasing by 5. So from negative 2 to the term after it, we are going to subtract 5. So minus 2 minus 5 is minus 7. Question 3.1.2 says, determine the nth term of the pattern. Since this is a linear pattern, I'm going to use Tn is equal to a plus d into n minus 1. A is the first term in the pattern, which is 8. The difference is negative 5, and then into n minus 1. Now I just expand and simplify. I'm going to get negative 5n plus 13. Question 3.1.3, determine the value of the 25th term. So T25 is going to equal negative 5 into 25 plus 13. And that's going to equal negative 112. Question 3.1.4, which term of the pattern is equal to minus 527? So minus 527 is equal to minus 5n plus 13. So I can take the 13 over and simplify. I'm going to get n is equal to 108. Now question 3.2 says 3x plus 1, 2x, and 3x minus 7 are the first three terms of a linear number pattern. Determine the value of x. Now for a linear number pattern, we have a constant difference, meaning t3 minus t2 is going to be the same as t2 minus t1. So t3 is 3x minus 7, so minus t2 is 2x, and that's going to equal t2, which is 2x, minus t1, so minus 3x plus 1. It's important that you use a bracket here, because if you don't, it's going to change the value of your final answer. Now we simplify. We're going to have 3x minus 2x, which is simply x. So x minus 7 is equal to 2x, and then minus 3x, and then minus 1. Now we can simplify. X minus 7 is equal to 2x minus 3x is minus x minus 1. So we'll take the x's over and take the numbers over. You're going to have 2x is going to equal 6. That means x is equal to 3. Now let's take a look at question 3.3. If the pattern Michael, Michael, Michael is continued in this way, what will the 201st letter be? So what I'm going to do first is I'm going to write write out the word Michael, M-I-C-H-A-E-L. This is the first, that's the second, that's the third, fourth, fifth, sixth, and seventh. So I'm going to divide 201 by 7. So that's going to tell me exactly how many full letters or how many full Michaels I'm going to have. So 201 divided by 7, which is equal to, now here we want a proper remainder like how you did in primary school. So this will be 28 remainder 5. So what this means is I'm going to have 28 full Michaels, and then I'm going to have M-I-C-H-A. So 1, 2, 3, 4, 5. Remainder 5 means that the letter is going to be an A. The 201st letter is going to be A. Now let's take a look at question 4. Given that f of x is equal to minus 2 over x plus 4, determine the equation of the horizontal asymptote. Now the horizontal asymptote is going to be this value here. So y is equal to 4. Question 4.1.2, determine the coordinates of the x-intercept. So to solve for the x-intercept, you make y 0. So 0 is equal to minus 2 over x plus 4. Now we can take the 4 across. You're going to have minus 4 is equal to minus 2 over x. Now what you can do is switch the x and the negative 4. So we'll say x is equal to negative 2 divided by negative 4. X is equal to half. Now they want a coordinate. So coordinate is going to be x first, so half, and y is 0. Question 4.1.3, sketch the graph of f, clearly showing the intercept with the axis and the asymptotes. So this is a hyperbola because it's some value over x. Because the value here is negative, it means that my parabola is going to appear in this quadrant here, and my hyperbola is going to appear in that quadrant and in that quadrant. I know that my horizontal asymptote is 4, so there's going to be a dotted line here at 4. In this case, my vertical asymptote is x is equal to 0, so that's fine. And so all I need to do is sketch in a curve like so, and sketch in a curve like so. And the x-intercept is going to be half. And that's my answer. Question 4.1.4, determine the equation of g if g is formed by shifting the graph of f 7 units down. So that's affecting the y value. So g of x is going to equal f of x, and we're shifting it down, so minus 7. So f of x is minus 2 over x plus 4, and then minus 7. So g of x is going to be minus 2 over x plus 4 minus 7 is minus 3. And that's my answer. Question 4.2, the graph of h of x is equal to 2 to the power x minus 2 is sketched below. Determine the coordinates of a. So a is the x-intercept, and to solve for the y-intercept, to solve for the y-intercept you make x 0. So I'm going to have y is equal to 2 to the power 0 minus 2. So 2 to the power of 0 is 1. So 1 minus 2, that's equal to negative 1. That means a is going to be 0 and negative 1. Question 4.2.2, write down the range of h. So range is referring to the y values that this function is going to appear in or cover. This dotted line here represents your asymptote. The graph will not exist below that. So to get the asymptote, all you got to do is read off this function. So my asymptote is y is equal to negative 2. So this function will exist for any y value above negative 2. So we can say that the range is going to be y is going to be greater than negative 2. If you want to write it in interval notation, you can write it as negative 2 and infinity. So you'll say y is an element of negative 2 to infinity. Question 4.2.3 says determine the equation of j if j is formed by reflecting the graph of h about the y-axis. So when you are reflecting something in the y-axis, you are going to keep the y value but change the x value. So if my function is y is equal to 2 to the power x minus 2, I'm going to keep the y, so y is equal to 2 to the power, so reflection in the y-axis, keep y, change x, x becomes minus x and then minus 2. That's my answer. Let's now take a look at question 5. Question 5.1, sketch below are the graphs of f of x and the straight line g. G is parallel to the x-axis and s is the x-intercept of f. The graph of f passes through the points T, P, and R. 5.1.1a, write down the coordinates of P. So 5.1.1a, write down the coordinates of P. P is going to be, now because this is a parabola, parabolas are symmetrical. So if the distance from here to here is 4, because it's 4 here, it means that that distance from there to there will also be 4. So since P is on the negative x-axis side, the coordinate for P is going to be negative 4 and 0. B, determine the coordinate for R. R is this value here. Once again, because a parabola is symmetrical, the distance from here to here, which we know is 2, is going to be the same as the distance from here to here, which is going to be 2. Since it's on the negative x side, it's going to be negative 2. And because that line G is parallel to the x-axis, the y value will be the same. So if the y value for t is 3, then the y value for r will also be 3. Question 5.1.2, write down the equation of g. So g, it's just a line, a horizontal line, so it's g of x is equal to 3. There's no gradient or anything like that. Question 5.1.3, determine the values of a and q. So a and q are the values that are appearing in the equation f of x. So I'm going to write out f of x is equal to ax squared plus q. Now because we know the x-intercepts of this function, we can use the x-intercept form. So I'm going to say f of x is going to equal a into x minus x1 and then x minus x2. So we also need to substitute a point here, but we'll do that now. So f of x is equal to a into x minus 1, x-intercept is minus 4, so x minus minus 4 is x plus 4, and then the other one will be x minus plus 4, so x minus 4. Now we need to substitute a point. Well, we can substitute either t or r. I'm going to substitute t. So t has a value of 2 and 3. So this is the y value, that is the x value. So 3 is equal to a into 2 plus 4 and then 2 minus 4. So 3 is equal to a times 6 times negative 2. So a is going to equal negative a quarter. So now I can write out my equation. I can say that f of x is going to equal minus a quarter x squared plus q. Now I can substitute a point again, or what we can do is we can substitute, let's substitute the point again. So let's substitute t again. So 3 is equal to minus a quarter into 2 squared plus q. So 3 is equal to, so this is going to be 2 squared, which is 4. So minus a quarter times 4 is minus 1 plus q. That means q is equal to 4. So the equation is now finally going to be, well, y is equal to minus a quarter x squared plus 4. Although they didn't ask us to solve for the equation, they just asked us to solve for a and q, so that's enough. Question 5.1.4, if f of x is equal to k, determine the values of k for which f has no x-intercepts. We have this function, right? This is our function. If we equate it to some value k, so minus a quarter x squared plus 1, and it's equal to k. Now they want to know what values for k will result in the function having no x-intercepts. Well, let's test. If k is equal to 1, then remember that's like saying y is equal to 1. Will it have an x-intercept? Yes, it will. If y or k is equal to 2, will it have an x-intercept? Yes, it will have an x-intercept. And you can go up and up and up and you can test. So the last value for y or k, if you want, is 4, because that's my maximum value. So anything above 4, there will be no x-intercept, because that is the maximum of this function. So for instance, if I had k is equal to 6, right? That line, or that imaginary line, doesn't touch the graph anyway. It doesn't cut the graph anywhere. And so there's not going to be any x-intercepts for that function, or for that line. Let's take a look at 5.1.5. Determine the coordinates of f if f is the reflection. Oh, the answer here then, y is going to be greater than 4, or k is going to be greater than 4. 5.1.5, determine the coordinates of f if f is the reflection of t about the x-axis. So if you're reflecting on the x-axis, you keep x, change y. So f is going to be, keep x, so 2, and change y, minus 3. Question 5.1.6, using the graphs, determine for which values of x, f of x minus g of x is greater than 0. So simply what this is asking, so f of x minus g of x is greater than 0. They are asking, where is the parabola above, because minus, it must be above the straight line. So the parabola is above the straight line between these values here, between 2 and minus 2. So we'll say that x is between minus 2 and 2. Question 5.1.6b. Where is f of x times g of x less than or equal to 0? So where is f of x times g of x less than or equal to 0? So because it's a product, we need to look at the different ways that we can get a negative answer. So we can get a negative answer if f of x is positive or g of x is negative, or if f of x is negative and g of x is positive. Now because g of x is a straight line that's on, well, it's a horizontal line that's on the positive y-axis, g of x is not going to be negative. So this option is out. So simply what we're looking for is, where is f of x going to be negative? So f of x is negative here. It's negative here. And it's negative here. So our solution here is going to be that x must be less than negative 2, or x must be x must be less than negative 4, or x must be greater than 4. Now let's take a look at question number 6. Tembekile wants to buy a laptop computer costing 11,500 Rand on a hire purchase agreement. The conditions of the agreement are as follows. Tembekile must pay a deposit of 20%. 11% per annum. Question 6. Tembekile wants to buy a laptop costing 11,500 Rand on a hire purchase agreement. The conditions are as follows. There's a 20% deposit, there's 11% per annum, simple interest, there's monthly insurance of 60 Rand 75 cents, and it's settled in 36 months. Question 6.1.1, calculate her balance after paying a deposit. So 6.1.1, she's paying a 20% deposit, so 20 over 100 multiplied by 11,500. That's equal to 9,000, no, that's 2,300. So the amount that Tembekile owes is 11,500 minus 2,300, which is 9,200. Question 6.1.2, calculate Tembekile's total monthly installment. So first let's figure out how much Tembekile owes inclusive of interest. So A is equal to P into 1 plus I times N. Tembekile owes 9,200 into 1 plus the interest rate is 11%, and 36 months is 3 years. That's equal to 12,236 Rand. Now, this is in total. So from here, what we can do is to figure out the monthly repayment. We're going to divide the 12,236 by 36. And not forgetting, we need to add the monthly premium, so 60,75. That's going to give us 400 Rand and 64 cents. Question 6.2, it costs £71.72 to fill a car with 55 litres of petrol in England. In South Africa, 1 litre of petrol costs 22 Rand 30. In which country is petrol more expensive? If the same car is used and the exchange rate between the countries is £1 equals 23 Rand 23 cents. So first I want to convert the pounds to rands. So for 55 litres in England, I'm going to say 71.72 multiplied by 23,23, and that's going to give us a value of 1666,06. So that's the cost of 55 litres in England, the Rand value. Now in South Africa, 1 litre of petrol costs 23,23. So 55 litres of petrol is going to cost 23,23 times 55. And that's equal to 1,226,50. So for 55 litres of fuel in South Africa, we are paying 1,226 Rand. In England, for 55 litres of fuel, you are paying 1,666 Rand. So England is more expensive. So England is more expensive. Now let's take a look at question 6.3. Brent crude oil costs $77.36 a barrel. Calculate the cost in rands of importing 100 barrels if the exchange rate is 17 Rand 83 cents. So here I'm going to first figure out what the cost in dollars is of 100 barrels. So 77,36 times 100, and that's equal to 773 Rand dollars and 60 cents. Now I can convert this to rands. So 777,36 multiplied by 1783, and that's equal to 137,932 Rand 88 cents. The last question, question number 7. The letters in the word coordinates were put into a hat. A letter is chosen at random. Determine the probability that the letter N is chosen. So from the letters of the word coordinates, there's only one N. So the probability of getting an N is going to be 1 out of the total number of letters in the word coordinates is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. So 1 out of 11. Question 7.1.2. The letter O is chosen. So there are 2 O's out of 11. So the probability of choosing an O is going to be 2 out of 11. Question 7.2. Balls numbered from 1 to 10 were put into a container. From the balls numbered 1 to 10, list the numbers that will be event A, the factors of 18. So the factors of 18, so let's call this event A. So event A is equal to, the factors of 18 are 1, 2, 3, 4 is not a factor, 5 is not a factor, 6 is a factor, 7 is not, 8 is not, 9 is. So that's event A. Question 7.2.2. From the balls numbered 1 to 10, list the numbers that will be event B, all the odd numbers. So the odd numbers from 1 to 10 are 1, 3, 5, 7, and 9. Question 7.2.3. Draw a Venn diagram to illustrate the above information. So my Venn diagram, I have 2 events, 1 circle, and because they are numbers that are overlapping, so there's 1 here, there's a 1 here, there's a 3 here, there's a 3 here, there's a 9 here, there's a 9 here, so the circles need to overlap. So circle there, circle there. I'm going to call that event A, that's going to be event B. The numbers that's going to go in between are going to be 1, 3, and 9. Then the rest of the numbers for A are going to be 2 and 6. The rest of the numbers for B are going to be 5 and 7. Now there are some numbers that we didn't use. For example, 8 hasn't been used, 4 hasn't been used, and 10 hasn't been used. So question 7.2.4 says, determine the probability of A and B. So A and B is referring to the overlap between A and B. So there are 3 numbers. So the probability of A and B. There are 3 numbers that's there. So the 1, the 3, the 9 out of the total of 10. Question 7.2.4b. Determine the probability of A or B. So A or B is talking about all of the values that are in A and the values that are in B, but obviously we're only counting the overlap once. So there's a 2, there's a 6, there's a 1, there's a 3, there's a 9, there's a 5, there's a 7. So there's 1, 2, 3, 4, 5, 6, 7 numbers out of a total of 10 numbers that are in A or B. So probability of A or B, there are 7 numbers out of 10 numbers that are in A or in B. And C, what is the probability of not A or B? Now because this is it's a bit of a tricky one, but I'll show you how to solve it. Not A or B. Let's break it up. So the first thing I'm going to do here is I'm going to put a cross for everything that is not A. So that is not A, and this is not A. Then I want to figure out what is B. So I'll use a tick here. So that's got a cross and that's got a tick. So that is B. This is also B. And now because this is an OR function, I'm going to take all of it. So I'm going to take whatever has a cross, whatever has a tick, and whatever has both. So there's this section. So let me use a highlighter. So there's this part, there's this part, and there's this part. So in total, there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers out of a total of 10 numbers. And that's the whole paper. Guys, if you stuck around till the end, please don't forget to leave a like, share, and subscribe for more videos like this. I'm going to be doing more past papers as we ramp up toward the final exams. And I'll see you in the next one. Bye-bye.